Okay, this is lab practical 3, which is an RL circuit. So we've got a series circuit, so the current runs through each component equally. However, the voltage across each component alters. We have our signal generator across the circuit, and the signal generator at the moment is at 100 Hz, 5 volts RMS. Okay, so if we look at the phasor display, we've got the phasor display connected up again. We've got the red connected across the resistance, 180 ohms, and we've got the yellow connected across the inductance at 47 millihertz. And then we've got the blue channel connected across the voltage supply. Okay, if we look at the phasor display circuit here, it's not doing what we thought it would do. We thought that the inductance would be leading the current by 90 degrees. However, the volt drop across the inductor is at a strange angle. So we need to look, why is that happening? I'm just going to crank the frequency up so it becomes a little bit bigger. So I'm going to put it up to about 600 Hz. And we can see, if I just bring the phasor display unit in, and we zoom in on the phasor display unit, we can see here that we've got 2.98 volts at 77 degrees ahead of the current. So the current is lagging the voltage by 77 degrees. We've also got this value here. And these are the rectangular coordinates of this vector. And what that means is this value here represents the volt drop across the inductor due to resistance, because an inductor is made of copper wire. The copper wire has a resistance, and therefore we have this amount of volt drop due to that resistance. And this amount of volt drop here is due to the reactance of the coil. So the resistance stays the same, however the overall reactance of the inductor varies with frequency. So if we go back down to 100 Hz, we can see that the volt drop across the inductor is very small. It's mainly at this frequency made up of the resistance of the coil. The reactance of the coil is quite small. So an inductor or a coil tends towards an open circuit the higher the frequency. At this frequency it is behaving pretty much as a short circuit. It's the resistance that is dropping the voltage. Okay, so if we increase the frequency to 200 Hz, we can see that the volt drop across the inductor has increased. However, now it's the reactive component of that volt drop that is the largest. So when you're taking your measurements, it's important that we take both the resistive and the reactive volt drop. Okay, so if you follow your lab notes, you keep increasing the frequency, keep taking the readings, plot the graphs that are required. Okay, off you go.